Steve Brown from Swansea Creatives, and this one here with Gary Wignall from West Wales Heating. We've been talking about different things, you know, that Gary's business does in terms of the heating installation, like solar panels and biomass, etc. One thing that interested me when you talked about these heat pumps, or whatever you call them. So, what are they?
Heat pumps are purely electrically driven equipment that basically comes under two banners. You've got air source heat pumps and ground source heat pumps. Okay. An air source heat pump extracts the heat from the air outside your house. It's like an air conditioning unit, size of box, for a better word, that's installed alongside your house, and it's got a fan on it, and it draws the air through a heat exchanger, and then through the mechanics inside the heat pump, which are very similar to the workings of a fridge. Right. Whereas a fridge takes heat from inside the fridge and throws it out at the back. A heat pump takes the heat, in the case of an air source, from the air, goes through a compressor and a condensing system, and multiplies the heat up, and then sends that to where you need it. And generally with an air source, that's a buffer cylinder. Right. Buffer cylinder is like a battery for heat. Right. And the air source heat pump will supply heat to that buffer, and then the buffer is there for your heating and your hot water demand as you need it.
Right, so explain that buffer to me again. So what sort of size unit are we talking about?
Generally a buffer cylinder is round about somewhere between 1 and 200 litres. Right. Much more commonly between 100 and 150 litres, so it's a much smaller cylinder than your hot water cylinder.
If I can quick, that's my my marine tank that I keep. You know, I've got a 200 litre marine tank, so I'm talking about a 3-foot tank, you know. So you're talking quite relatively small.
Yeah, I mean they're a round cylinder, generally round about sort of the 500mm diameter, and you know they stand sort of
quite small.
Yeah,
okay.
Yeah, and that's a buffer cylinder that the heat is stored in, ready for use when the house needs it. Now, air source heat pumps. When you look up and you're looking for a heat pump, something you'll see written down in the manufacturer's literature is a COP. Right. Now, a COP is coefficient of performance, and it's the efficiency of the machine. Okay. And generally, with an air source heat pump, you'd be looking at something like 3.5, 4.5 COPs. Okay. Now, what that means is it's 350 to 450% efficient. Right. Now, when you compare that to an oil and gas boiler, modern oil and gas boiler are 98% efficient, which means that you're putting in, you know, for argument's sake, a kilowatt of energy, and you're getting 98% of that back. Yeah. With a heat pump, you're with a COP of 3.5, 4.5, which equates to an air source unit. You're putting in a kilowatt of electric, and you're getting 3.5 to 4.5 kilowatts of heat out. Right. Which is the magic of them. They're incredibly efficient.
So who would actually use them? I'm trying to picture now. Who would actually use this sort of system? Who's your typical customer for this?
For heat pumps, I would say 70% is domestic market for us. 30% is the commercial side. The commercial sides tend to be air source units because what you can have is, instead of an air source heat pump that's air to water, you're taking the heat from the air, you're transferring it to water and using it. Right. You can also have air to air systems, where you take the heat from the air and then you give it out in the form of an air with a unit on a wall. Yeah.
Which we all see in commercial.
Yes, and you've got large open spaces. It's a general.
And on the domestic side, you know, I know you say domestic, but so. What sort of client? Are we talking about somebody on a housing estate? Are we talking farms? What do you mean by domestic?
Well, domestic, exactly that. It can be properties on housing estates, it can be farms, detached properties and so on. Okay. With an air source heat pump, you've got very little in terms of space you need to install it. Right. I mean, they can be hung, and we've done it in some installations, where the unit is actually hung on a bracket on a wall. Right. So, I mean, I don't know, if you went to Europe, you see quite common flats and things that have a little balcony attached to it. There's a little air source heat pump on the balcony, and that's supplying heating and so on to that property. Okay. More generally in the UK for domestic installations, it is a ground source system that's installed. A ground source system is where you have a unit inside the property, the actual heat pump is inside the property, and you're extracting the heat generally from the ground.
Right.
It can be generated from lakes, ponds or rivers and such like, but I would say the vast majority is from the ground.
Right.
There's two ways of doing that. One is where you're extracting the heat from a borehole,
right.
Which is a hole that's drilled by machine, and it generally goes down between 80 and 100 metres.
Okay, that's a lot.
It's a big hole, yeah. The machinery used is usually trap laying and can get through where a normal van can get through, so access is quite easy in that sense. But it boils down, and then you put down a factory-made pipe with effectively a U-bend in it.
Right.
Drop that pipe down, and that's true geothermal heating system. And again, we put down a fluid that's a mixture of glycol and water, and it goes down in the borehole. It picks up the heat that's down in the earth, brings it back up, and that is then multiplied up by the heat pump itself. And again, it can go into a buffer cylinder. Properties with underfloor heating generally don't need a buffer cylinder. It's going straight through the underfloor heating and heating a hot water cylinder.
Right.
The other approach to ground source, which requires a little bit more land, useful amount of land, so you need to have a big garden or a paddock or a field or something adjoining the house, is where you put loops in the ground in trenches that are just excuse me, just below about a metre of depth.
Right. So that's very similar then to underfloor heating. Yeah,
in a sense, yes. Instead of giving out the heat, you're extracting the heat. And generally you're looking at somewhere around 450 to 600 metres worth of loops, which are divided into 3 or 4 loops. Each loop is around about 150 metres, which runs round the ground and then back to a manifold. All the loops join into a manifold inside a chamber, and then you have a pair of pipes coming from that manifold to your heat pump.
Right. But it sounds very neat to me because it's obviously everything's...
Yeah, once it's installed, generally all you have is the cover of the chamber for the manifold, and you can't see anything else. Right. The ground's reinstated, your garden's reinstated, whatever. Okay. That's the only access that's ever required. Okay. A heat pump itself is, you could argue, is smaller than a modern fridge. Right. It's the same width, perhaps a little bit deeper, but it only comes up to sort of chest height. Right.
So again, another installation that could go into a utility room.
Exactly. Absolutely, goes into a utility room. And yes, I mean, just moving on, we were talking about COP earlier of an air source unit being 3.5 to 4.5. A ground source unit is certainly up into the 8.5s now.
All right.
So you're talking something that's up to 850% efficient. Right. Ground source costs a great deal more to install than an air source unit.
Which you'd expect, yes.
Quite so.
Are they supported under this, what do you call it, the RHI?
Correct. Yes, they are. Absolutely they are. And again, the payments vary between air source and ground source due to the cost of installations rather. But again, you're looking at over a 7-year period of payments, which is for the domestic scheme. Again, 3 or 4 years, you'll have your installation paid for.
I am genuinely amazed at, such a short time span. Okay, so guys, we've just been talking about, ground pumps and air pumps, and I was genuinely interested to know how these things work. So if you want to know more, you can go to the website. You can ring Gary and his team on the website, and we'll see you all in the next video.